The channel Job is Yours invites you to discover the 20 most popular questions and answers for a job interview for the role of artificial intelligence engineer. Don't forget to click the like button and subscribe our channel for more.
What experience do you have with neural networks? I have extensive experience working with neural networks, including designing architectures, training models, and optimizing performance. I am proficient in various types of neural networks such as feed-forward, convolutional, recurrent, and generative adversarial networks. I have applied neural networks to various tasks such as image classification, natural language processing, and time series prediction. Can you explain your experience with machine learning algorithms? I have a solid understanding of various machine learning algorithms, including supervised learning, unsupervised learning, and reinforcement learning. I have implemented algorithms such as linear regression, logistic regression, decision trees, random forests, support vector machines, k-means clustering, and deep reinforcement learning. I have experience in selecting appropriate algorithms for different tasks based on data characteristics and problem requirements. Have you worked with natural language processing (NLP) tasks before? Yes, I have worked extensively on natural language processing tasks such as text classification, sentiment analysis, named entity recognition, part-of-speech tagging, machine translation, and text generation. I am familiar with NLP libraries and frameworks such as NLTK, Spacy, Transformers, and BERT. I have experience in pre-processing text data, building word embeddings, and fine-tuning pre-trained language models for specific downstream tasks. How do you stay updated with the latest advancements in AI and machine learning? I am passionate about staying updated with the latest advancements in AI and machine learning by regularly reading research papers, attending conferences, participating in online courses, and engaging with the AI community through forums and meetups. I follow top conferences such as NeurIPS, ICML, and CVPR to stay informed about cutting-edge research in the field. Additionally, I contribute to open-source projects and experiment with new techniques by implementing them in personal projects and experiments. Could you walk me through a complex AI project you've led, covering its inception, challenges faced, solutions implemented, and the key takeaways? I led a project to develop an AI-driven document classification system for a legal firm. Challenges included unstructured data and limited annotated data. We used deep learning, transfer learning, and active learning to address these challenges. Collaboration with legal experts and at teams was crucial. The deployed solution reduced manual efforts, resulting in cost savings and improved efficiency. Can you discuss a challenging AI project you worked on and how you overcame obstacles? One challenging AI project I worked on involved developing an anomaly detection system for network security. The project required analyzing large volumes of network traffic data to identify abnormal patterns indicative of cyber threats. One of the main obstacles was dealing with imbalanced datasets where normal instances significantly outnumbered anomalous instances. To address this, I employed techniques such as oversampling of minority classes and adjusting class weights during model training. Additionally, I experimented with various anomaly detection algorithms such as isolation forests, one-class SVM, and autoencoders to find the most suitable approach for the task. By iteratively evaluating and fine-tuning different models, I was able to achieve satisfactory performance in detecting and mitigating cybersecurity threats. How do you approach feature selection and engineering in machine learning projects? In machine learning projects, I approach feature selection and engineering as crucial steps in improving model performance and generalization. I start by conducting exploratory data analysis to understand the distribution and relationships between features and the target variable. I use statistical methods, correlation analysis, and domain knowledge to identify relevant features and discard irrelevant or redundant ones. Additionally, I perform feature scaling, transformation, and normalization to ensure that features are on similar scales and have meaningful representations for the model. I also leverage techniques such as feature encoding, binning, and aggregation to extract useful information from raw data and create informative features. Have you deployed machine learning models to production environments? Yes, I have experience deploying machine learning models to production environments using containerization, cloud services, and microservices architecture. I have deployed models on platforms such as Amazon Web Services, AWS, Google Cloud Platform, GCP, and Microsoft Azure, using services like AWS SageMaker, Google Cloud AI Platform, and Azure Machine Learning. I containerize models using Docker and orchestrate deployment using Kubernetes for scalability and reliability. Additionally, I integrate models with RESTful APIs and build monitoring and logging pipelines to track model performance and detect drift. How do you handle overfitting and underfitting in machine learning models? Overfitting and underfitting are common challenges in machine learning models that can degrade performance and generalization. To address overfitting, I employ techniques such as regularization, dropout, early stopping, and cross-validation. Regularization methods such as 1-lira and 2-lira regularization penalize large coefficients to prevent model complexity and overfitting. Dropout randomly deactivates neurons during training to prevent reliance on specific features or interactions. Early stopping monitors validation performance and stops training when performance deteriorates, preventing the model from memorizing noise in the training data. Cross-validation assesses model performance on multiple train test splits to obtain robust estimates of generalization error. For underfitting, I focus on increasing model complexity, adding more features, or using more expressive architectures to capture underlying patterns in the data. How do you evaluate the performance of machine learning models? Evaluating the performance of machine learning models is essential to assess their effectiveness and identify areas for improvement. I use various metrics depending on the task and nature of the problem, such as accuracy, precision, recall, F1 score, ROC-OC, and mean squared error. For classification tasks, accuracy measures the proportion of correctly classified instances, while precision and recall quantify the trade-off between true positives and false positives or false negatives. F1 score combines precision and recall into a single metric that balances both aspects. ROC-OC evaluates the model's ability to discriminate between positive and negative classes across different probability thresholds. For regression tasks, mean squared error measures the average squared difference between predicted and actual values. I also use techniques such as confusion matrices, precision recall curves, and calibration plots to gain deeper insights into model performance and behavior. Can you discuss a time when you had to troubleshoot and debug a machine learning model? During a project at OVW Analytics, I encountered an issue with a deep learning model for image segmentation that produced unexpected results on new data. After investigating the problem, I discovered that the model's predictions were sensitive to variations in input data preprocessing. To address this, I carefully examined the data preprocessing pipeline and identified inconsistencies in scaling, normalization, and augmentation techniques across training and inference stages. I standardized the pre-processing steps and ensured consistency in data transformations to eliminate discrepancies between training and inference environments. Additionally, I implemented logging and visualization tools to monitor intermediate outputs and identify potential sources of error during model inference. Through systematic troubleshooting and debugging, I was able to diagnose the issue and improve the model's robustness and reliability for real-world deployment. What is your experience with deep learning frameworks such as TensorFlow and PyTorch? I have extensive experience with deep learning frameworks such as TensorFlow and PyTorch, having used them in various projects for model development, training, and deployment. I am proficient in building neural network architectures, defining custom layers, and implementing advanced optimization algorithms using both TensorFlow and PyTorch. I have worked with high-level APIs such as Keras for rapid prototyping and experimentation, as well as lower-level APIs for fine-grained control over model training and execution. Additionally, I have experience in deploying TensorFlow and PyTorch models to production environments using frameworks like TensorFlow Serving and TorchServe. Have you worked with cloud-based AI services such as AWS SageMaker or Google Cloud AI Platform? Yes, I have experience working with cloud-based AI services such as AWS SageMaker, Google Cloud AI Platform, and Microsoft Azure Machine Learning. These platforms provide end-to-end solutions for building, training, deploying, and managing machine learning models at scale. I have used AWS SageMaker for model development and training, leveraging its built-in algorithms, Jupyter Notebook integration, and distributed training capabilities. Google Cloud AI Platform offers similar functionalities with seamless integration with other GCP services, such as BigQuery and Dataflow, for data pre-processing and analysis. Additionally, I have experience using Azure Machine Learning to develop and deploy machine learning models in Microsoft Azure's cloud environment, benefiting from its rich set of pre-built containers, SDKs, and DevOps integration for CI/CD workflows. How do you handle imbalanced datasets in machine learning projects? Imbalanced datasets pose challenges in machine learning projects where one class is significantly underrepresented compared to others. To address this, I employ various techniques such as oversampling, undersampling, synthetic data generation, and class weighting. Oversampling techniques such as SMOT, synthetic minority oversampling technique, generate synthetic samples for minority classes to balance class distributions. Undersampling randomly removes samples from the majority class to achieve a balanced dataset. Synthetic data generation methods such as generative adversarial networks, GANs, create artificial samples that resemble minority class instances. Class weighting assigns higher weights to minority class samples during model training to compensate for their scarcity. Additionally, I use evaluation metrics such as precision, recall, and F1 score that are robust to class imbalance and provide meaningful insights into model performance. Can you explain transfer learning and how you have used it in your projects? Transfer learning is a machine learning technique where a model trained on one task is reused as a starting point for a different but related task. It involves leveraging knowledge gained from a source domain to improve learning in a target domain, typically by fine-tuning pre-trained models or using them as feature extractors. Transfer learning is particularly useful when labeled data is scarce or when tasks share underlying patterns and structures. I have used transfer learning in various projects, such as image classification, object detection, and sentiment analysis. For example, I fine-tuned pre-trained convolutional neural networks, CNNs, like VGG, ResNet, and Inception on custom datasets to perform specific image recognition tasks. By reusing features learned from large-scale datasets like ImageNet, I accelerated model convergence and achieved competitive performance with limited labeled data. Additionally, I have used transfer learning with pre-trained language models such as BERT and GPT to improve performance on natural language processing tasks such as text classification and sentiment analysis. How do you ensure the ethical use of AI and machine learning in your projects? Ensuring the ethical use of AI and machine learning is paramount to building trust, fairness, and accountability in AI systems. I adhere to ethical principles and guidelines such as fairness, transparency, accountability, privacy, and inclusivity throughout the project lifecycle. I conduct thorough risk assessments to identify potential biases, discrimination, and unintended consequences in AI models and algorithms. I prioritize fairness by mitigating biases in training data, feature representations, and model predictions through techniques such as bias detection, fairness-aware learning, and algorithmic audits. I promote transparency by documenting model assumptions, limitations, and decision-making processes to facilitate understanding and scrutiny by stakeholders. I advocate for accountability by establishing governance frameworks, oversight mechanisms, and responsible AI practices within organizations. Additionally, I respect user privacy and data rights by implementing privacy-preserving techniques such as anonymization, differential privacy, and data minimization. Lastly, I foster inclusivity by considering diverse perspectives, needs, and impacts of AI technologies on different stakeholders and communities. How do you handle missing or noisy data in machine learning projects? Handling missing or noisy data is essential for building robust and reliable machine learning models. I employ various techniques such as data imputation, outlier detection, and error correction to pre-process and clean data before model training. For missing data, I use methods such as mean imputation, median imputation, and k-nearest neighbors imputation to fill in missing values based on observed patterns in the data. I also consider domain knowledge and context-specific information to inform imputation strategies and avoid introducing bias or distortion into the data. For noisy data, I employ outlier detection techniques such as z-score, Tukey's method, and isolation forests to identify and remove outliers that deviate significantly from the norm. Additionally, I use error correction methods such as robust regression, robust PCA, principal component analysis, and robust clustering to mitigate the impact of noisy observations on model estimation and inference. By applying these techniques judiciously, I ensure that machine learning models are trained on high-quality representative data and produce reliable predictions in real-world scenarios. Can you describe a time when you had to explain complex technical concepts to non-technical stakeholders? Communication is crucial in bridging the gap between technical concepts and non-technical stakeholders in AI projects. I have experience distilling complex technical concepts into clear and accessible explanations tailored to the audience's background and expertise. In one instance, I was tasked with explaining the architecture and functionality of a deep learning model for image recognition to senior executives and business partners. I prepared visual aids such as diagrams, flowcharts, and slides to illustrate key concepts and processes in an intuitive and engaging manner. I avoided jargon and technical details that could overwhelm or confuse non-technical stakeholders, focusing instead on high-level insights, implications, and actionable takeaways. I also encouraged interactive discussions, questions, and feedback to ensure mutual understanding and alignment on project goals and expectations. By adopting a collaborative and inclusive communication approach, I facilitated informed decision-making and fostered trust and buy-in from stakeholders throughout the project lifecycle. How do you prioritize and manage multiple tasks and deadlines in a fast-paced environment? Prioritizing and managing multiple tasks and deadlines in a fast-paced environment requires effective time management, organization, and communication skills. I employ strategies such as setting clear goals and objectives, breaking down tasks into smaller actionable steps, and allocating resources and time accordingly. I use tools such as to-do lists, calendars, and project management software to track progress, monitor deadlines, and coordinate with team members. I prioritize tasks based on urgency, importance, and impact on project milestones and deliverables. I communicate proactively with stakeholders to manage expectations, identify dependencies, and resolve conflicts or bottlenecks that may arise during project execution. Additionally, I leverage agile methodologies such as Scrum and Kanban to adapt to changing requirements and iterate on deliverables in short development cycles. By maintaining a flexible and proactive approach to task management, I ensure that projects are completed on time and within budget while meeting quality standards and stakeholder expectations. Can you discuss a time when you had to work collaboratively in a team environment? Collaboration is essential in AI projects, where diverse expertise and perspectives contribute to the success of the team. I have experience working collaboratively in multidisciplinary teams comprised of data scientists, engineers, domain experts, and business stakeholders. In one project, I collaborated with data engineers to design and implement data pipelines for collecting, pre-processing, and ingesting large-scale datasets into machine learning models. I worked closely with domain experts to understand business requirements, domain-specific constraints, and regulatory considerations that informed model development and deployment decisions. I collaborated with software engineers to integrate machine learning models into existing systems and applications, ensuring seamless interoperability and scalability. Additionally, I facilitated knowledge sharing, code reviews, and best practices adoption within the team to promote continuous learning and improvement. By fostering a culture of collaboration, trust, and mutual respect, I contributed to the team's success in delivering innovative AI solutions that drove business value and impact.
Would you like to receive the script of all the discussed questions in a Word document? Leave a like, click the subscribe button, and in the comment section, provide your email address to which we will send our top 20 Q&A. Did you enjoy the video? Share your opinion in the comments. Would you like us to prepare 20 Q&A for another job position? No problem. Let us know in the comments, and we'll do our best to prepare it as soon as possible. Thank you, and feel free to check out other Q&A on our channel.